Okay, in today's section we're going to talk about zero and negative integral exponents. In the last video we looked at algebraic expressions involving exponents. In this section we're going to do the same thing. The only difference is these exponents are going to either be zero or they're going to be a negative number. So really this entire section boils down to two things, and if you can remember these two things it's going to be easy as cake. And I'm going to go ahead and write them up here in the upper right hand corner and leave them there as we work these problems. The first thing is x raised to the 0 power is by definition 1. That is a universal truth. It's absolutely true, and it's always going to be true. Now x here can be anything. X could be 1, so 1 to the 0 is 1. X could be 59, 59 to the 0 is 1. X could be some massive expression in parentheses and the whole thing raised to the 0 power. By definition, anything raised to the 0 power is 1. The second thing is, I'm just going to pick a different variable to be cute. Let's say y raised to the negative x, where y is some number and x is some number, is the same thing as 1 over y to the x. These are two things that I'm going to leave up here on the board, and we're going to leave them there to stare at us right in the face during the course. The only thing you have to remember, anything raised to the 0 power is 1, and if you take anything and you raise it to a negative power, that's the same thing as taking 1 and dividing by that letter to the power. Okay, so let's just go through some examples, and this is going to be just really simple. This is the most general case. Let's get to some real examples. Let's say I have something like 2 to the 5th times 2 to the minus 2. Okay, I want to simplify this, and I want to simplify each of these expressions without using any parentheses, and I don't want to use any negative exponents. Well, let's go ahead and use these rules. First of all, 2 to the 5th, nothing changes there, so I'm just going to write that down, 2 to the 5th. Now I've got an exponent, something raised to a negative power. So I'm going to just say this is equal to 1 over 2 squared. Look at this and look at this. 2 raised to the negative 2 is the same as 1 over 2 raised to that power. So all you do is strip the negative out and do 1 over it, and that's it. And this is absolutely true. If you were to take 2 and then put it in your calculator and raise it to the negative 2 power and get that number, it would be the same thing as 1 over 2 to the 2. Just like that. Now, further, if I want to simplify this, this is simply, this is really a fraction. 2 over 5 is the same as 2 over 5 over 1, 2 to the 5th over 1. So this is really 2 to the 5th over 2 to the 2nd. And we can reduce this fraction because I have essentially, and I'm going to do this blown out in the first example to make it clear. On the top I have 2 times 2 times 2 times 2 times 2, that's 2 to the 5th, over on the bottom I have 2 times 2. Now in fractions like this, when I have lots of things multiplied together, anything on the top can cancel with the same thing on the bottom, because I've got 2 over 2, that's 1. I cancel this 2 with this 2, that's 1. So on the bottom I just simply left with 1, and on the top I'm left with 2 times 2 times 2, which is 2 to the 3rd. That's the long and drawn out way to simplify this. I do not expect and I do not recommend you to simplify the expressions by writing it out. What you can simply do is look at this and realize that I have 2 to the 5th on top, 2 to the 2 on the bottom, and I can simply subtract these two. 5 minus 2 is 3, so the answer is going to be 2 to the 3. Another way to do it is just looking at this. I've got 2 2's in the bottom and I've got 5 2's in the top, so I can cancel this 2, and 5 minus 2 is 3, so I can write a little 3 up there to remind me, and so the answer is just going to be 2 to the 3. We're going to do so many of these, this is going to seem old hat, so let's just keep on going. Let's say I have 3 to the 5th, okay, times 3 to the minus 2 over 3 cubed. Okay? Let's go ahead and take care of our negative thing first. So I'm going to have 3 to the 5th on the top. I'm going to move this quantity down to the bottom. How do I do that? Well, I've got to keep the 3 to the 3 intact, but I'm going to move this down and make it a 3 squared. All I did was I moved it downstairs and I took the sign off. So all you do is take the sign, you move it downstairs, okay? So then on the top I've got 3 to the 5th, and on the bottom I've got the same base, so I can simply add these exponents. So I've got 3 to the 5th, okay? 3 to the 5th over 3 to the 5th is simply 1. Anything divided by itself is 1. Another way to simplify this is just an alternative way, is to say, okay, I've got 5 here and I've got 5 here, so this is going to be 3. 5 minus 5 is 0, because I can subtract the top exponent from the bottom exponent because they have the same base, and anything to the 0 power is 1. So one way to look at it is I've got the same thing on the top and the same thing over bottom, so it's like 2 over 2 or 5 over 5 or 10 over 10 or whatever. I can divide anything by itself and I can get 1. Or I can do it the exponent way and say I'm going to simplify this by just taking 5 minus 5 gives me 0, and then anything to the 0 power following the first rule gives me a 1 by definition. So we're going to be using some skills today that we've developed in previous lectures. Namely, we're going to be figuring out how to simplify fractions. The only real difference being that we're going to, I should say, we're going to be simplifying algebraic expressions. The only real difference is some of these exponents are going to have negative numbers in there. So let's take another one. 2 to the 5th times 2 to the 7th over 2 to the 6th times 2 to the negative 3. Now, my job is to teach you how to work a variety of problems, and I'm going to try to teach you to do different problems different ways. So, you know, in the previous two problems we've moved the negative, you know, upstairs. Okay. But I'm going to mix it up a little bit, and I'm going to show you a couple different ways first. I don't have to deal with this negative first. I could, but I don't have to. I'm going to choose to deal with this over here. I've got 2 to the 6 on bottom, and I've got this junk on the top. Well, I can cancel this out and strike the 7 and just put a 1 up here, because 7 minus 6 is 1. I have the same base on the top as I do on the bottom, and 7 minus 6 is 1. So I can basically divide. What you're doing here when you do this is you're dividing the top by the bottom by the top and the bottom by 2 to the 6 power. 2 to the 6 divided by 2 to the 6 is simply 1. That's why it disappears. And on the top, 2 to the 7 divided by 2 to the 6, 7 minus 6 is going to give me 1. So if I were to rewrite this, I would have 2 to the 5 times 2 to the 1, okay, over 2 to the negative 3. That is what happens when I start to cancel these things. Basically, you look for commonality of things in the top and the bottom. I have 2 raised to something in the top, 2 raised to something in the bottom, and I can just simply subtract those exponents and arrive at the simplify thing, which is right there. So how would I continue to simplify this? And we have this negative exponent, okay? Well, this thing works in reverse, okay? I can move this upstairs, so I can say I have 2 to the 5th times 2 to the 1 times, and I can move this thing upstairs by saying 2 to the 3rd. Basically, with these negative exponents, you can move them up and down all you want. It's just that when you move it upstairs, you've got to make the negative exponent, you've got to change it into a positive exponent, and if the negative exponent's up here, when you move it down, you're going to make it a positive exponent. So all I did was I moved this upstairs and I changed this to a positive number. Okay? Now I can simplify this whole thing because I've got an exponent with the same base. So our rule for exponents from the previous lesson is I can simply add the exponents. So 5 plus 1 is 6, 6 plus 3 is 9. And that's 2 to the 9th power. And that's the answer. Okay, let's say I have 2, this is mixing it up a little bit different, 2 times x to the 0 power. Well, that's going to be 2, and x to the 0 is 1, by definition is 1, so this is going to be times 1. So the answer here is simply 2, because this x to the 0, another way to write this is draw an arrow through it and just put a 1 there, just to remind yourself that that whole term goes to 1. 2 times 1 is 2. So that's that. Okay. So it's not that bad. And if you want to get a little bit more fancy, I mean, just to show you the extent of this, what if I have something like a squared b to the third over a b to the fourth, something like this, all raised to the 0 power. Again, the entire thing is raised to the 0 power, so that's just going to equal a big fat 1. No matter what goes in here, it could be huge, but if the entire thing is raised to 0 power, the end result is going to be 1. That's just a mathematical definition. That's kind of like saying 3 is greater than 2. I mean, that is just a definition. How do you know 3 is greater than 2? Well, somewhere someone decided that that was just going to be the way it was, and they were going to develop math, you know, based on those assumptions. Well, somewhere someone decided that anything raised to the 0 power was going to be 1, and that's just the way it's going to be. Okay, so what if I have something like x to the negative 2? How does that go? Well, by definition, you see, I can move it up or downstairs as long as I change the sign. So I'm going to choose to move this downstairs, and so x to the minus 2 is going to simply be equal to 1 over x squared. So you can move them up, because remember, there's an implied divided by 1 here. Any number, there's an implied divided by 1, so I can choose to move it downstairs and change the sign of the exponent. There's no problem there. My job is to show you what's legal in algebra. Your job is to figure out if you should do it or not. Let's say I have 2y raised to the negative 4th power. Well, I've got some quantity raised to a negative power. It's currently upstairs because there's an implied divided by 1 here. So I can simply make this equal to 1 over 2y to the positive 4th power, and I can move it downstairs and make that positive. And I could just leave this as the answer, but I'm going to go ahead and simplify it just a little bit more, because remember, if I have from the previous video, if I have two things and the product of them are raised to the power, I can simply write that as 2 to the 4th y to the 4th, and you can look in the previous video for that. So that is the full-blown simplification of this. Okay. Now what if I have something like y to the 4th over y to the 5th? Okay. Well, I've got 4 y's on the top, you know, y times y times y times y, and on the bottom I've got 5 y's. 5 y's. Y times y times y times y times y. So I've got extra number of y's on the bottom. I've got 4 on the top and 5 on the bottom, so I can cancel all 4 of them on the top, and I can cancel all but 1 on the bottom. So the answer is going to be 1 over y to the 1st power, which is simply 1 over y. Basically, if you have exponents in the top and the bottom, you just look at the exponent, okay? Whichever one's bigger, which in this case the bottom one's bigger, he's going to be the one that's going to win out. And all you do is subtract them to figure out what the exponent is. Okay? If the y to the 5th were up here and the y to the 4th were down here, it'd be y over 1. But because y to the 5th is bigger, then he wins out and the y stays on the bottom, and so I subtract the 2, and it's just going to be like that. You can kind of think of it as, y times y times y times y, and on the bottom I've got y times y times y times y times y. Well, I can cancel all of these with all of these, so I'm left with 1 over y. That's the long way to do it. Okay? The short way is you just look at the numbers. Whichever one's bigger, he's going to have a y, and to figure out what the exponent is, you just subtract the 2. And like I say, we're going to do a whole lot more of these to make that concept clear. That can be confusing, but it's really not that bad, and we're going to work through a whole lot of these things to make it a whole lot more clear. Okay. Now let's say, what if we have something like, continuing on with simplifying these exponents, y to the 4th times y to the 3rd over y to the 4th times y to the negative 2. Okay? there are a number of ways you could do this. I mean, first of all, let me just let's just solve this problem like 3 different ways. I'm going to show you like 3 different ways, 3 different orders in which you can do it. Okay. First of all, notice I've got, this is method number 1. Okay. Method number 1. First of all, I got a y to the 4th on the top and a y to the 4th on the bottom, and all this junk is multiplied together. So I can cancel immediately the y to the 4th and the y to the 4th. They could just go away. That would leave me with y to the 3rd over y to the minus 2. The y to the 4th can be canceled because it's the same thing on the top and the same thing over bottom. Anything divided by itself is 1. Then further, I could move the y to the negative 2 upstairs, and that would give me a y cubed times y squared. I just moved it upstairs and made it positive. And then to simplify this, 3 plus 2 is 5. So that would be y to the 5th. That is the answer. That's method number 1. I canceled these first, and then I proceeded. Method number 2, let's say I don't cancel these first. I'm going to show you something else. Well, what if I combine the exponents in the top and I combine the exponents in the bottom? You can look at it here. They're all exponents involving y. So on the top, if I simplify that first, that would be y to the 7, because 4 plus 3 is 7. And on the bottom, even though it's negative, that's okay. I can still add it, just like I can do with all exponents. So that would be y to the positive 2, because 4 plus negative 2 gives me 2. Okay? And then when I simplify this, it's simply going to be y. 7 is bigger, so what's going to happen is I'm going to cancel all of these. 7 minus 2 is 5. So I'm going to be left with y to the 5th, because 7 minus 2 is 5. All of the 2's go away on the bottom. They get sucked up, canceling two of these y's up here, and I'm left with 5 y's up there. And then the third way is to move the 2 upstairs first. So let's say I do that. I've got y to the 4th times y to the 3rd, and I can move the 2 upstairs, so that's going to y squared. I can move it upstairs. It's going to be y squared, positive 2. I moved it upstairs, over y to the 4th. Okay? And let's say I simplify this. This is going to be y. 4 plus 3 is 7. 7 plus 2 is 9. Y to the 9th over y to the 4th. As I added these up, gives me y to the 9th, y to the 4th in the bottom. And this, the way I simplify this is I just subtract the exponents. I've got an exponent divided by an exponent. It's the same base. It's going to be y. 9 minus 4 is 5. So you see, in all 3 cases, I got exactly the same answer. So you're going to find in algebra that that's going to be the case a lot of the time. That there's going to be a few different ways to solve the problem at hand. And your way may be different than the teacher's way. In fact, your way may be better, or even simpler, or different, or heck, even longer and more complicated than the books. But that doesn't mean that your way is incorrect. Okay, let's say I've got x to the negative 4, x to the 3rd, cubed, let's say. Okay, how am I going to go ahead and do this? Well, first, I'm going to simplify the inside. I've got x to the minus 4 times x to the 3rd. I can simplify that by adding these 2 exponents. Negative 4 plus 3 is negative 1, and this is all raised to the 3rd power. X to the negative 1 is simply 1 over x, and this is all again raised to the 3rd power. And this is simply, remember, when you have a fraction raised to an exponent, it's 1 raised to the 3rd power over x raised to the 3rd power. You just put the power to the top and the bottom separately. 1 times 1 times 1 is simply 1 over x to the 3rd. And that's the answer. And what if I have a to the minus 2 times b to the minus 3 over raised to the negative 4th power? Okay. Again, I'm going to show you a couple of different ways to do it. or not a couple of different ways. I'm going to show you a different way. I could, take these and I can move them downstairs, and then I can flip the fraction around and all that. But this way, I'm just going to do it just like typical. When I have some terms in here and they're all raised to the power, I can sort of distribute the exponent in to each thing. So that what this is going to be a to the minus 2 raised to the minus 4 power times b to the minus 3 raised to the minus 4th power. All I did was raise each thing individually, which is the case from the previous video. And then how do I actually simplify this? Well, when I have an exponent raised to an exponent, I just multiply the numbers. So this is going to be a. Negative 2 times negative 4 gives me positive 8. And then over here, negative 3 times negative 4 gives me b to the 12, positive 12. And that's how you do it. There's many ways you could have done this. You could have moved these downstairs and then applied the exponents and all that kind of stuff. I just chose the most direct path that I saw, which was to go ahead and just, quote, distribute this exponent in. Now, I want to caution you to be a little bit careful. I'm using terms like distribute the exponent in, and I'm using those terms because I'm not trying to be mathematically rigorous with the definitions. I'm just trying to get the point across to you to what to do. So be careful when you tell the teacher, oh, just distribute it in. She might, he or she might get upset at you because that's not maybe not the exact terminology, but that's pretty much what you're doing. Okay, so proceeding, let's say we have something like a to the 3rd over a to the minus 4th, all raised to the 2nd power. Okay. Again, it's all how you want to do it. I'm going to choose to move this a to the negative 4 upstairs. So I'm going to have a to the 3rd times a to the positive 4, and that's all raised to the 2nd power. All I did was move this bottom thing upstairs and make the exponent positive. Next, I'm going to simplify the inside. This is going to be equal to a to the 7, and that's going to be raised to the 2nd power. 3 plus 4 is 7. And then how do I do this? An exponent raised to an exponent, you multiply them. It's going to be a. 2 times 7 is 14. And that's the answer. Okay. Now let's say we have something a little bit different. Let's say we have negative 3r to the 4th r to the negative 3 divided by r to the negative 3 r to the 7th, all raised to the 3rd power. Again, there's many ways to do it. I'm going to choose to look at these r to the minus 3 on top and r to the minus 3 on the bottom. I've got the same thing on the top that I do on the bottom. This is all being multiplied together, so I can just simply cancel this with this. It's the same thing as saying that something times 2 divided by 2, the 2's go away. I can cancel those. So let me go ahead and rewrite it. That's one thing you need to learn from algebra. You need to go ahead and rewrite everything after every step. That will really help you. Notice I always do this in the class, and I always do it in real life. Go ahead and simplify it. Okay. Now how do we proceed now? Well, I've got these r's on the top and I've got these r's on the bottom. I can simplify that. Again, let me rewrite it. Negative 3. And then I've got 4 r's on the top, r times r times r times r, and then I've got 7 r's on the bottom, r and then times itself 7 times. So this entire r to the 4 is going to cancel, and on the bottom I'm going to be left with r cubed, because 7 minus 4 is 3. So I've got negative 3 divided by r to the 3rd, and that's all again raised to the 3rd power. I canceled all 4 of these r's, and I canceled 4 of the ones down here, and that left me with 3 left. Now when you have a fraction, you apply the exponent to the top and to the bottom separately. So I've got negative 3 times raised to the 3rd power over r cubed raised to the 3rd power. On the top, negative 3 times negative 3 times negative 3 is going to be negative 27. You can check that in your calculator. And then on the bottom, r cubed raised to the 3rd power is simply r, and then 3 times 3 is 9. So you see, we're making some progress. Not that big of a deal. We're just going to work a few more of these, and then we're going to call this section done. This stuff that we're doing now is bread and butter algebra. Okay, you're going to really get good at this stuff, and it's going to make your life easier. I promise. Let's do one a little bit harder. Let's say we've got 18 a squared b to the third c to the minus fourth all over 3a to the minus 1 b squared c. And this entire quantity is raised to the negative 3 power. Okay. Well, first note, I've got an 18 on the top and a 3 on the bottom, so I can divide top and bottom by 3, so I can cancel this 18 and I can write a 6. There's going to be you can't really see that. There's a 6 on the top here. Okay. Again, I got b cubed, and I got b squared on the bottom, so I can cancel these b's, and I'm going to cancel that because 3 minus 2 is 1, so I'm going to be left with 1b on the top. Now let's go ahead and rewrite that just to kind of get it all squared away. What I'm going to have is 6a squared b c to the negative 4 over a to the negative 1 c. And this is all raised to the negative 3 power. Okay. Let's say I want to move the c to the 4 downstairs, and I want to move this a to the negative 1 upstairs. So that's going to be c a squared a to the 1 b over c times c to the 4th. All I did was move the c to the 4th downstairs and the a upstairs. And this all goes to the negative 3, which is simply going to be 6a cubed, 2 plus 1 is 3, b over c to the 5th. And this entire thing is still going to be to the negative 3 power. And that's the answer. Okay? I want to do a couple problems of a different type. Let's say we have x to the 2m times x to the m. Now these are exponents like any other, it's just that I have m's there instead of numbers. What's this going to equal to? Well, it's going to be x, and then I'm going to add the exponent, so I've got 2m plus m, which is simply going to be x to the 3m. Okay? That's how you simplify something that looks like that. And finally, the last problem I'm going to show you, what if I have y to the 3m plus 2 times y to the negative m. How do I simplify that? Well, again, I've got the same base. I'm going to add the exponents. So that's going to be y 3m plus 2 minus m. I'll just add the two things. And that's going to be y 3m minus m gives me 2m plus 2. Just like that. And that's about all I had for this section of the class. I mean, again, the whole lesson is centered around these two things. You get these two things straight here, you're good to go. And just pounding in, over and over, how do you simplify exponents? When they're multiplied together, you can add them. When they're on the top of a fraction and the bottom, you subtract them, and so on and so forth. And this is going to be etched in our brain more and more as we go through the course. Pretty much from here on out, we're going to be using these skills. So that about does it for 0 and negative integral exponents.